Slag is not a waste product, it is a liquid engine of the furnace. So today we focus on oxide balance, the basicity trap and the magnesium anchor. So these factors we need to introspect to BF team. As in this slide, in the hearth, iron stays below and slag float above because of density difference. If slag become too viscous, the drainage worsen and productivity falls. So these are the principal fundamental that we have to keep in mind while operating the furnaces. Now, good slag need balance between CaO, SiO2, MgO and Al2,3, where these all four oxide constitute 94 to 95% of the slag. So too much alumina pushes viscosity too high and makes tapping very difficult. And thereafter, we trap totally. So this is supposed to be the first step, that whatever we make, we architect, we engineer in the hearth of the blast furnace, that should flow easily. Now coming to the part of a basicity. So basicity is the mm, main control dial. So high basicity improves desulfurization, but it also raises melting point and reduces slag fluidity. As for the desulfurization is concerned, as we have just moved the slide in advance, so slag removes sulfur from the hot metal, but only if it is stay liquid. So we must have to keep the slag fluid lesser stronger. As far the Poisson number is concerned, that means more fluid. So if we chase a very high basicity, the slag can become too stiff to work effectively. Thus, we need to have a fluid basic slag. If basic, that means fluid slag. So coming to the our magnesium anchor part. So this is a very important one, where we know that this MgO helps flatten the viscosity curve and protect slag fluidity during the temperature drop. But too much MgO reverse the benefit and makes slag harder to tap. So we need to very aware about that maximum optimal point. So we should not cross over that, and again we have got a, in that case we have a bad consequences, especially in terms of viscosity of slag, drainage of slag. So coming to the basically a basicity trap. So during a stop or blow-in, silicon pickup can reduce silica in slag and sudden increase the basicity. So that is why the acid burdening is used to keep the slag system safe. And in each shutdown cases, the operator need to capture all these innovative ideas during burdening in advance. Coming to the slide of basically the situational matrix, which is also very important. And as it is shown that different furnaces problem need different slag strategies. Normal running, hearth accumulation and a scaffold cleaning each require a different chemistry response. Thus this diagnostic guide template is very important for operator, and please go through it, and in case of any doubt it can be clarified. So coming to our synthesis slag so as you know, the slag design is always a compromise between sulfur removal, thermal stability, flowability and lower slag volume. So we need to keep the balance of all these four components. So good operation means balancing all four, not maximizing only one. So these are overall basically the our execution, and based on this balance execution, our furnace stability will be more, production will be highest.